Assalamualaikum warahmatullahi wabarakatuh. My name is Fitriaty Pangerang. I will introduce my research with the title Variable Loaded Brushless DC Motor with 6-step commutation PID-based speed controller optimized by PSO algorithm. My affiliate, Department of Electrical Engineer Hasanuddin University, Indonesia. The team research are Faizal Arya Samman, affiliate Department of Electrical Engineer Hasanuddin University, Zahir Zainuddin, affiliate Departemen Informatik Hasanuddin University, Rhiza and Sadjad, affiliate Department of Electrical Engineer Hasanuddin University. BLDC motor are essential element for most real-life application. It has been widely used in many industrial, household, commercial, and automatic applications over the past few years due to its advantages such as control flexibility, high-torque capability, silent operation, more efficiency, smaller size, and volume compared to conventional motor. The 6-step commutation method is a method that is often used to determine commutation change timing because it's easy to implement and has a simple algorithm, but causes torque removal and overshoot, especially in a wide speed range. This research introduced an approach to a BLDC motor speed control method in voltage mode control with a voltage control DC bus voltage control mechanism. The voltage supplied to the inverter use a control source voltage based on a comparison of the reference speed and the actual motor speed drop in feedback loop. Simplicity is maintained by controlling the DC bus voltage with closed loop negative feedback that keep the loop gain constant over varying input voltage. PID control is used so that the simplicity of structure is maintained. PSO algorithm for strengthening control gain with control characteristic of minimum root mean square error, RMSE, and minimum overshoot. The control target is that the motor speed remains stable with minimum torque ripple, current ripple, and overshoot ever under load condition and speed change. The research with present contribute to introducing a simple and easy control method and little computation in the algorithm so that it can reduce electrical power consumption in its application, but remain efficient, especially in a wide speed range. This diagram the proposed BLDC motor speed control system. The system consists of a DC voltage source, a 6-step commutation inverter circuit, and a PID controller. The source voltage will be controlled by a DC-DC converter and produce a controller output voltage activity, a 6-step commutation inverter circuit which produces 3-phase currents. The signal given to the converter will determine the value of the output voltage. This signal is a function of the application factor, duty cycle, on the switch, namely the comparison of time between the on condition of the switch to one switching period. By setting the work factor, the output voltage can be adjusted. The Hall effect sensor will detect the magnetic field from the coil facing toward it. The Hall effect sensor then provide data signal to the commutation control regulating the commutation of BLDC motor. to implement a PID control, controller using a digital computer, the continuous equation is converted to a different equation using the direct discretization equation method. PID control gain using algorithm particle swarm optimization. PSO is a technique based on the natural properties of certain group of animals such as ant, bee, termite, and bird. The step of the proposed algorithm, one initializes PSO parameters, evaluate the fitness value. The fitness value is the reliability of particles to survive in a population. The smaller the fitness value is directly proportional, the more reliable the particle is to survive in a swarm. Function fitness is minimum root mean square error plus minimum overshoot. Step 3, update the particle velocity using equation 22. Update the particle position using equation 23. The mind loop at fitness function start doing the calculation to update the particle position in each iteration. If the new amount is superior to the previous P-base, then the new amount adjusts to P-base compatible and the number of G-base is also updated is a better P-base. Step 6, the process of staging for the base particle position continues until the number of iterations is reached and the PID gain value is obtained at the minimum root mean square error and overshoot condition for all existing iterations. This table parameter of PSO algorithm. Maximum iteration 100, number of population, the inertia coefficient 1, damping factor 0.48, personal acceleration coefficient, and social acceleration coefficient 9. Result: testing and simulation of control design are evaluated in the PSI Altair simulator platform. In this simulation, the BLDC motor is operated for 2 seconds and given a load of 148 Newton meter. The simulation results are compared with experimentally simulated tuned PID, hybrid gray wall optimization, proportional integral, and hybrid horse head particle swap optimization. Motor speed response. The purpose of the test is to determine the response of the motor actual speed to the reference speed. The signal plot in figure shows that there is a speed spike in all control methods when the motor starts to operate, unless the trial and error PID method is no longer able to respond to initial speed. When a change in speed occurs, only the proposed control can respond to the speed without oscillation, while the other controller experience oscillation. The control signal response was also analyzed in terms of root mean square error and overshoot percentage criteria. The results are presented in table. The proposed control has a smaller RMSE and overshoot error percentage. These results show that performance of the control system in responding to speed is superior to other compared control method. electromagnetic torque response. This test aims to see or response of electromagnetic torque to change in motor speed when loading occurs. The signal response is shown in figure. In figure 4E and 4B, the signal response show a spike in torque with light oscillation when there is a change in speed. This condition lasts long as the motor is operation. Manual figure 4C, it shows the occurrence of a torque spike with a long interval at the initial speed. In the proposed control method figure 4D, the signal response shows a torque spike, but a short time interval only at the initial speed and the signal response to stability. Compared with other methods, is so that the electromagnetic torque response of the proposed control method can adjust its torque to change in speed compared to other methods. In this test, torque ripple was also measured as shown in table. The results show that the proposed control method has a smaller percentage of electromagnetic torque ripple compared to other control methods. Three-phase current response. This test aims to determine the phase current response in BLDC motor stator when change in speed and loading occur. The signal response is shown in figure 5. In this test, the total harmonic distortion is measured to determine the magnitude of the ripple generated by each phase. In figure 4E, current fluctuation occur in each phase, reaching 25 ampere and occur with change in motor speed. Likewise, in figure 5B, current fluctuation occur up to 643 ampere. In figure 5C, a current surge of 542 ampere with a long duration occur at the initial speed. In the proposed control method figure 5T, a current surge also occurs. A current surge also occurs at 5 ampere and lasts briefly at the initial speed. The phase current spike that occurs is smaller compared to other methods. This condition shows that the electrical current consumption in the proposed control method is relatively small. The total harmonic distortion is shown in table 5. A lower total harmonic distortion is produced by the proposed control, indicating that resulting current ripple is less compared to other methods. Conclusion: in this study, simple but effective speed control is achieved using the proposed PSO-based PID control for BLDC motor. The proposed control is compared with other control under pariwing loaded and speed condition. Control system performance are mean square error, overshoot, and the influence of control on electromagnetic torque ripple. Three-phase current ripple and phase current total harmonic distortion have been measured, analyzed, and compared. The results show that the PID-PSO control outperforms all the controllers in responding to reference speed, reducing current ripple and electromagnetic torque ripple with smaller RMSE, current ripple, and electromagnetic torque ripple value. The proposed method can improve the speed response performance of BLDC motor, especially over a wide speed range. However, further research is still needed regarding reducing current surges, especially at initial speed. That is an overview of this recess. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.